Good morning, everyone, and welcome to today's online seminar, Training and Retraining All Along the Value Chain. I'm Irene Saiz, and I'm working for the European Heat Pump Association, which is the organizer of this session. Not long ago, we learned that for triggering the renovation wave, the European Commission plans to support member states to update their national roadmaps for the training of the construction workforce. Here in EHPA, we believe in the importance of training and retraining professionals, and above all, in the importance of upskilling the installers of traditional heating and cooling systems, as we know that only well-informed professionals can ensure a high-quality building renovation and offer the latest available energy-efficient and renewable alternatives to end users, such as heat pumps, for instance. Training, learning, both are lifelong processes. New challenges emerge every day, and those new challenges require that we learn new skills. And that's why we are here today, to introduce 4 innovative initiatives that, while facing challenges, strive for fostering new skills in the energy sector. As you might know, because you might have attended other episodes in the past, this is the 4th episode of the Project Online Talks, which is a series organized by EHPA. This is a series that focuses on heat pump applications in different sectors. I invite you to keep an eye for other episodes coming next year, as well for other EHPA related events on the EHPA website. Since we are here today, I would like to introduce an initiative in which EHPA is involved in, and that is highly related to the topic we're discussing here today. Heat Pump for All is a Horizon 2020 project that aims to enhance, develop, and promote the skills required for high-quality heat pump installations in European buildings. Now, Heat Pump for All is looking for creating an expert panel to provide guidance and support in the development of the process. If you would like to be part of this group of experts, or you would like to learn more about it, do not hesitate to contact me under irene.egea at ehpa.org. I will be glad to answer all your questions. Going back to today's online seminar, I would like to go briefly through the agenda. After my welcome speech, which will end up soon, we will start with the first presentation, which will be given by Johann Zirngibi. He will present you new challenges, request new skills in the context of the CEN-CE Project. Then we will proceed with a presentation by Serena Scotton, dedicated to the training of the next generation of heating and cooling professionals in the context of the project Heat for Cool. Then we will continue with a presentation by Richard Cochrane, and he will present you heat pump design skills and training proposals from the GeoAtlantic project. And finally, last but not least, we will conclude with the presentation by Julie Beaufils that will present the initiative Skills for Climate. All the speakers will have 15 minutes for the presentation. Then there will be a Q&A session at the end of the webinar. I want to kindly ask all the audience that if you have any question, you can address the speakers through the Q&A section that you have available. And I would also ask to please indicate the name of the speaker you want to address the question to. Then some general rules. Please, speakers, stick to the timing and mute your sound so we can avoid background noises. And in general, for all the audience, all these presentations and the recording of the session will be disseminated from tomorrow. And this is all. Now, in a second, we will start with the presentation by Johann. Okay. Then, Johann, now you might start.
Hello, thank you, Irene, for having introduced my presentation. My name is Johann Zirngibi. I am senior scientist at CSTB. CSTB is the scientific and technical center belonging to the French Ministry of Housing and dealing with quality in buildings. I'm working very much on European standardization and also ISO standardization. and I have the pleasure to present you the new challenges in the building sector, requesting new skills. I forgot to say that I am also the coordinator of the CEN-CE project. So what is CEN-CE? CEN-CE stands for CEN Standard Certified Experts. It's a European-wide training and qualification scheme based on EPBD, so Energy Performance of Building Directives, mandated CEN standards. It is also a H2020 project on construction skills and with the target to reducing energy consumption, carbon footprint, and of course, the market uptake of energy innovation. So what was the reasons for the CEN-CE project? We think that to reach European energy and climate targets, a qualified building workforce is needed. And of course, present professionals need to be trained on the upcoming challenges, like near zero energy buildings 2050 ready. But I will come to these points a little bit later in my presentation. And this is why CEN-CE project target is to set up a European-wide training, and I insist on European-wide training and qualification scheme. So just a few key data to remind the importance of the HVAC professionals, but I think all of us, we are convinced that we can play a major role in this renovation. But just to remind you some key data. So the buildings, it's well known that the buildings currently account for 40% of the Europe's total energy consumption, 30% of its CO2 emissions, and mostly for heating and cooling. But the building stock, European stock, is very old because 35% are over 50 years old, and only nearly 75% are energy inefficient. Even if renovation of existing buildings could reduce significantly energy consumption, only 1.2% of buildings are renovated each year, and only 15% incorporate significant energy efficiency improvements. So this means that, unfortunately, until today, energy savings is not the main topic to trigger, for example, building renovation. So heating systems have also an important market share. It's about 20 billion euro. This is coming from the TC228 website. And this key data was just to show you, to underline that the HVAC professionals play an important role in energy efficiency update, and especially in renovation, where HVAC systems are often upgraded first. So what is the HVAC system evolution and the new challenges? So I insist again on system and not products, because we are looking in the CEN-CE project on the system approach and not only on the product approach. And the CEN-CE is addressing white-collar workers, so mostly designers. So just to show you the evolution in the past, for the designers, was very much important to dimensioning rightly the heating systems. So it was a thinking on kilowatt, and it was related to power of generation, emission, etc. So it was dimensioning and sizing. The products were characterized as products and not as part of the systems. So it means that the products were mostly characterized at nominal power and with a related efficiency. So it's changed already, because now the dimensioning of the heating systems is still important, of course, but also the energy consumption. So now we are talking about kilowatt hours are important to get the building permit. And this is already a change, of course. But unfortunately, very often the evaluation of this energy consumption is mostly related to be compliant and to fulfill the regulations and to real performance, because very often only monthly calculation methods are used, and they are not always very, precise. So the products are characterized now also by part load, not only by nominal power as before. So we have the eco design and the EHPA directive. And they're also a part of a system because, for example, the energy performance of building directive is not evaluating product by product, but is evaluating the building as a whole, and the main indicator is primary energy. So in the future, now we are looking on the new challenges, what we are talking today, and the future starts already this year because nearly zero energy buildings, new buildings should be, all new buildings should be near zero energy buildings after the end of this year. The problem again is the definition of the nearly energy buildings. It is not harmonized European-wide because in Europe we have 35 regional methods. So this is a very fragmented market. The building are not longer energy users, but also energy producers. So this is also an important change. And then, of course, we have European targets, which is to be Europe wish to be CO2 neutral in 2050. So we have the Green Deal, we have the renovation wave, and we have a huge European funding, but we think that the European funding needs also to have European comparability to be efficient. We have to avoid a building gate. It means that this is a relation with a diesel gate, because the calculated energy consumption should be close as possible to the real consumption. And the evaluation of the HVAC systems should be related to real performance, not only to fulfill regulations or requirements. And of course, there is a big change of systems from fossil fuels to renewables, which means there is more storage, there is less power, there are more complex interactions between the systems, which are more sensible to on boundary conditions. So for example, the heat pumps. And here again, because we are talking storage, we are talking about less power, we are talking about interaction. The system approach is very much important. So these evolutions are new challenges already taken into account in the new set of European standards related to HVAC systems. And this is why the CEN-CE trainings is based on these European standards. Just an example on the new requests, for example, related to building code requirements. I just show you here very quickly on my slides evolution of the assessment perimeters, so the assessment boundaries. At the beginning, we started in the building regulations with the products. We have only limited. We had requirements related on the building, on the windows, on the bricks, etc. Then the next step was the requirement was related to the needs of the building, heating needs, for example, but didn't take into account the system. And then the building and the system, for example, heating, cooling, lighting was taken into account. This is where we are now, mostly in Europe. So we are still on the building side, but there is more and more interaction also, which is something which happens outside the building. So there is more interaction because the building is not only energy consumer, but also energy producer. And this is why we go now until to primary energy. And as I said already before, the performance indicator of the European Directive on buildings is the primary energy indicator. So this shows you the evolution of the building codes and the parameters. So after the new challenges and the requested new skills, now some words on the new skills related to the whole HVAC building change. So for example, I start with the professionals. The professionals needs to be trained on more complex HVAC systems, more renewables, more storage, more interaction. There are more boundary conditions dependence. I said it already, as the heat pumps. And we have also new indicators. People should be sure about it, like the share of renewables. And then the perimeter, energy, primary energy on-site, nearby or distance, because all these things are requested and mentioned in the European Performance of Building directives. And even some countries today, not only the primary energy consumption is mandatory, but also the share of renewables. So I think especially for HVAC, for heat pump systems, this is very much important. What is the renewable part of a heat pump? And then industrials need, for the industrials, it is very important to have a common level playing field for a fair competition between the products and for the optimization of the building energy performance. Because as I said before, building energy performance is related to the building permit. And it is very much important that the market is not so much fragmented, but there are common tools all over Europe. This is an important part of the industrials, and this is also related to the common databases and tools, software tools. And we can see that HVAC systems are still the weak point in the software tools. And then again, I told you already that the CEN-CE training scheme is based on European standards. And why? But because we think that it is an advantage for mutual recognition of qualifications among European member states. And this is a very much important point, because today, unfortunately, people which are trained in France cannot work in Germany, cannot work in Italy, because you need specific qualifications related to the regional evaluation methods. So the qualification and training scheme should be recognized European-wide. This would be a huge advantage for the building professionals. And then, of course, it is key to create a level playing field, as I said already before, common databases, transparent evaluation, and things like this. And then the first European-wide qualification and training scheme based on EPB mandated CEN standards has been created, and this is the CEN-CE scheme. So what is the content of the CEN-CE training scheme? First of all, I want to recall the general structure of the building energy assessment. So in the European standards, the assessment goes, so the energy flows, for example, goes in this direction from primary energy to the generation, then it comes to the building, to the generation, storage, etc. So this is the energy flow, but the calculation direction goes from the demand for the energy needs, building needs, to the source, to the primary energy. And so here it's again building needs, then becomes to system losses, then becomes to delivered energy, and primary and HVAC professionals are concerned by system losses, delivered energy, and primary energy consumption. So in this approach, the energy losses inside the building are calculated explicitly. Emission, we have standards related to emission, direction, generation, for example, and the losses outside the building and the related emissions are taken into account in one factor, which is the primary energy factor and the CO2 emissions. So this was a general structure of the calculation methods in the European standards. And now just to show you what is the content of the training, of the CEN-CE training. So we have different things. First of all, we have like a PowerPoint presentations where you have things related to the instruction, to the physics, fundamentals, input data, calculation methods, etc. And here on the screen, I showed you, for example, the fundamentals related to heat pump systems, so basic heat pump types. And then also I just showed you an example about the physics, thermodynamics here on the screen, which are also mentioned in the trainings. And then to make it more practical, for each standard, we have a spreadsheet to allow the trainees to analyze the impact of the different parameters. So it is very small, but you cannot, so maybe you cannot see it. But for example, here you have the input data. For example, he can choose the location of the heat pump. He can choose which heat pump types he has, and he can choose, for example, the boundary conditions related to the temperatures. And then he can have a graphical output, and he can also have a a more detailed output, things like this. And then he can play with it and he can see what is the influence when he changes the temperature, when he changes the heat pump and things like this. And then we have different things, but we have also set up a CEN-CE training platform. Where you can have online training on the different topics I just showed you before. And then at the end, you can also make the exam online and things like this. And then you can get at the end, you can get a certificate. And as a CEN-CE certificate, here I showed you on the screen. It looks like a driver license where you have, here's the different possibilities. So it is a modular structure. It is standard by standard. And here you have all the standards on your license, on your certificate. And if you have passed the test on the different standards, then this will be indicated also in your certificate. And now I am on my last slide. So what are the CEN-CE outcomes, to resume them? So for building professionals and industrials, we think that can be a gain of recognition for the performance, comparability, and reliability. So these are very much important topics because it is based on the best know-how, because it is based on the European standards. Then it is a harmonized procedure. So we have on the training and tools to allow hopefully professionals to work European-wide. So this is still a target, but we are doing we are trying to bring it into practice. Then the advantage is that there will be European harmonized databases. This is very much important for industrials. And it is a coherent and transparent level playing field, as I said already several times before, because it is the European standards are technology neutral for in the energy performance assessment of buildings. So to finish, to reach the European energy climate targets, we are convinced that a qualified building workforce is needed, and HVAC professionals need to be trained on new upcoming challenges. This training should be harmonized at European level, recognized all over Europe, and this is a target of the CEN-CE project. So if you want to have more information, here you have my contact address, and you can see you have how to find more information or to register on trainings, things like this. You can have, I put also on the screen, the CEN-CE website. Thank you for your attention. This finished my presentation.
Thank you very much, Johann, for your presentation. Now, in a second, we will start with the presentation by Serena Scotton. Whenever you are ready, you can start your presentation, Serena.
Thank you. Good morning, everyone. I'm Serena Scotton. I'm working for the European Heat Pump Association. Today, I'll present you the Heat for Cool project and what are the training and education activities foreseen in this project. Just a second, I'm trying. Okay. Sorry. There is a short delay. So I would like to first introduce you the project, as you have an idea of what is the framework and what is the topic, and for then connecting it with the training activities. So the Heat for Cool project is an European funded project in the framework of the Horizon 2020 program. And the project is composed by 13 partners. And the goal of the project is to demonstrate easy to install energy efficient heating and cooling solutions for the building renovation. The Now we are in month 49 of the project, so it will end in 5 months from now, and we aim at demonstrating that with these energy solutions applied in the project, we can save in between 20–30% of energy savings compared to the pre-retrofitting situation in a payback period of less than 10 years. And we are also developing business models thus to allow these system operations to be replicated once the project ends. So in the project, we have 6 different technologies involved. We go from adsorption heat pumps to solar PV assisted heat pumps, solar thermal collectors, latent heat storage. We have an intelligent building energy management system, and we do thermal energy recovery from sewage water. So all these technologies are coupled together to provide heating and cooling solution, both at building and district level. These technology packages have been testing in 4 demo sites in Europe. So in Sciorzo, Valencia, Sofia, and Budapest. The first 3 demos are only residential applications, while the demo site in Budapest, here we have a district heating cooling application. The key innovation on these projects, in this project are, so maybe I forgot to mention. So in this project, we have 6 technologies. When we started the project, these technologies already have a quite high TRL. Now, of course, during these 3.5 years, we raise the TRL of the technologies that now they are ready to enter in the market. So the developments that we have done, for example, in the thermally driven adsorption heat pump that is provided by our partner Fahrenheit. In this case, we have a heat pump that is using the silica gel technology and is also using water as refrigerant. So we are adopting an environment-friendly solution on the refrigerant side. This heat pump is providing cooling in our demo site and can be powered both by renewable sources or waste heat. What is, let's say, different from similar other units already in the market is that this is a really compact unit and there are no movable parts. So these allow this makes the installation easier for the installer, and since there are no moving parts, these also allow silent operations of the unit. Then another important technology involved in the project is the PCM storage provided by Sanab. In this case, we are using a heat pump, which is the first heat pump with a direct refrigerant connection to PCM storage. This unit can be used both for heating and cooling and hot water. In our case, in the project, we are using it for only for the heating part. As you can see from the image, if we compare the PCM storage on the right side to a normal water heater already present in the market, we see that the unit is way more compact. Indeed, there is a 56% of volume reduction. This makes it perfect for residential application. I imagine apartments where you need to where you have compact space, but you don't want to lose in high performances. This unit is also using a dual ported heat exchanger that allows simultaneous charge and discharge. Then another innovation or important part in our project is the intelligent building energy management system. So in all our demo sites, we are using the SHIBEMS, which is basically taking and monitoring the data from the sensors installed in the rooms of the apartments. The collection of this data allows to create personalized profile of the user. This is also connecting with demand flexibility estimations, and it brings us to create an optimization strategy for the heating and cooling performances in the apartments. Then another key innovation part of the project is the wastewater heat recovery system that we have created in Budapest. This is a very simple schematic of the district heating cooling application in Budapest. So basically what we are doing is simply taking the sewage water, which is a heat source available in all cities. The water goes to the screening station. Then it goes up to the heat exchanger, which then pump the heat pump and allows to raise the temperature and provide hot water, to the buildings. In this application, in this demo site with this system, we have a district heating structure of 12,500 square meters, providing heating and cooling to 3 big buildings, so to the New Market Hall, Mayor's Office, and Government Window in Budapest. As you can see, these are really completely different buildings because we go to historical buildings built in early 20th century to brand new buildings built 2 years ago. Then a really short overview on the other building demo sites that we have in the Heat for Cool project. So it's the 3 residential demo sites. In Chorzów, for example, we are testing the direct current heat pump with the PV panels and the PCM storage in 12 apartments. So we are supplying 12 apartments for and 60 tenants. In this demo site, we are only supplying for the heating part. Then we have the demo site in Sofia, in which we are testing, same technologies, so PCM storage, PV panels, and the heat pump. In this case, is a smaller building because it's only 4 apartments and 4 floors. Then we have a bigger demo site in Valencia, and so we completely changed the climate area. In this demo site, we are supplying 12 apartments. The technologies installed are the adsorption heat pump, solar thermal collectors, storage tanks, and air-to-water heat pump. In this demo site, we are both supplying heating and cooling. So after this overview of what the project is about, now I'll go more into details about the trainings. So the trainings that we have foreseen in the framework of the Heat for Cool project is that we want to train both the maintenance operators and the researchers and R&I managers in the SMEs on the industrial side, and also to reach the general users. Why? Because as I said, the project is ending in 5 months. Our technologies are ready to enter in the market. So we want to, of course, inform users about the system that we have developed within the project. We want to demonstrate the data that we got, so from the energy savings part, but we also want to inform and train operators on how these machines are working and also how to install them, which we know is a really important topic. So in the framework of these two different training, let's say that unfortunately we faced some obstacles because we started the training more or less also when the lockdown started. So the starting idea was to, of course, have some physical trainings that, as you know, they are much easier when you need to showcase technologies and also to visit the demo sites. But unfortunately, due to the lockdown and also to the current health situation, this is not possible. So we had to adapt to the situation and we organized online training in May 2020. In this online training, all the technology providers and the demo site managers were present and presented in details how the technologies work, how the different technologies are coupled and how they are running in the demo sites. Also showing some videos of the installation and also providing really interesting insights to cover all the questions from the installers and R&I managers. This online training was recorded, and as you can see, they are also published in the Heat for Cool website in the training page. And we divided each topic in a video, so that's to allow an easier accessibility from the users. We also prepared some training materials, also available in the website. For the time being, we are also sharing this material with targeted stakeholders. As I said, unfortunately, as of today, all these activities have been implemented online. In this training material, we aim at cover all the possible questions, both from the installer's part and from a more, and also to a user part, in the sense that we think is really important to understand how technology works and how it can be coupled with other technologies that to provide an efficient and innovative package to be then applied and to be bought also from users once it will be in the market. But to be honest, yes, these training materials is more maybe for users and R&I managers, then more technical documents on operation, design, installation is provided by other training and guidelines, in which here I simply took a screenshot, but these guidelines are available in different languages, English and then the other languages of the country in which we have the demo site. This is what we have done for the moment. Of course, now with the upcoming months, we would like to adopt different trainings. We would like to really organize physical meetings just to also better engage with the stakeholders. But for the time being, we have to adapt also our strategy. Nevertheless, I invite you, if you have any questions, you can use the Q&A. Otherwise, you can send me an email. And here is the link where you can find all the training material and the education activities that we are developing in the Heat for Cool project. Thank you very much.
Thank you very much, Serena, for your presentation. Now, in a second, we will start the next presentation by Richard. If you give me a second. Here it is. And then, Richard, whenever you're ready, you can start.
Great, thank you. Good morning, everybody. So my name is Professor Richard Cochrane from the University of Exeter in the UK. We have our main campus in Exeter, but then most of our renewable energy work is done on the Cornwall campus, which is based near Falmouth in the southwest of Cornwall. And with the team here have done work on a number of areas. We've got strong links to the Camborne School of Mines, which is part of the University of Exeter, which has done a lot of work on deep geothermal in the past. And then our renewable energy systems group work on a range of topics: offshore renewables, solar, energy policy, energy storage, and increasingly picking up work on low carbon heat and options there. So there's two projects that we have related to this presentation today. The first one is our GeoAtlantic project, which is supporting both deep geothermal and ground source heat pumps in the Atlantic region of Europe. And it's been quite an exciting time in that sector. I mentioned Camborne School of Mines. We've got colleagues there who were looking at enhanced geothermal energy systems, power generation, 80s and 90s, quite a while ago, and pushing for a long time to get funding to do these projects. And what's been really exciting is that they finally got to go ahead with those. So just up the road from our campus at a site called United Downs, we've got the first deep geothermal in the UK going ahead. So they've drilled down 5 kilometers into the granite, tapping down to temperatures of about 193, 197 degrees centigrade down there. And then looking at, they're doing flow testing at the moment and are looking at both power generation and using the heat from that system for a number of businesses around. Other deep geothermals going ahead. So the high profile one with the Eden project is just about to start drilling, similar down into the granite, and aspiring to get to similar depths and temperatures with their system there. So with the GeoAtlantic project, we've been trying to support those schemes, studies of different opportunities for heat from the Eden project, those sort of things. Now the GeoAtlantic project includes ground source and includes training. So we've done some work, which I'll touch on training requirements in the sector. This is also linked with another project, the IHLS project, which is innovation in higher level skills. And there we've been working with industry to understand what skills requirements are needed in a number of areas, including, and what I'm going to talk about today, is the design of heat pump systems. So for heat pumps in the UK, again, it's also been quite an exciting time. We're really seeing good growth in the sector. The majority of the UK heating is done by gas boilers, and still millions of those being replaced every year. So there's a great opportunity for heat pumps to come into that sector. We are still a tiny proportion of what's being fitted in new build or in retrofit, but the growth is there. So we are seeing progress. There is good training for simple domestic installations, retraining plumbers, particularly on how to fit a heat pump different from perhaps their usual work fitting a gas boiler. But we found there is a real lack of higher level system training. So larger projects, whether that's a large building or a network of multiple houses, those sort of systems. But actually even on individual homes, we are seeing some poor design. So just to illustrate some of those areas, a couple of projects. This is the building that I'm actually sitting in today, is our renewable energy engineering facility on the University of Exeter. And when we got the funding for the project and pushing it ahead, and we're very keen that it was going to be a green building heated with a heat pump. And partly through university procurement systems, we aren't able to select the engineers who design that. But these were, in theory, globally renowned engineers to design the system for us. And it was shocking, really, how poor their design of what should have been a very simple heat pump system was. Effectively, they were using crude calculations that they would typically do for sizing a gas boiler to specify a heat pump. So it was grossly oversized for the heat demand of the building. They used inappropriate design temperatures, so an external design temperature which we don't see in this region of the UK. And they had no consideration for things like occupancy of the building. The building can only run between 9 and 5 days a week. So they assumed it was heated 24/7 all through the year. It ended up, yeah, ridiculous. Almost, it was unviable to go ahead with the heat pump they recommended on that system. In the end, we've got a much smaller system and had quite a lot of work to try and explain to the engineers how they should have designed the system, what the constraints were going forward. Another example, what should have been a simple domestic installation. Company here came in and the client wanted to know about heat pumps, air source or ground source. The contractor here recommended an air source heat pump, which was again done on simple calculations without considering things like energy efficiency. With the air source, they would have to, there were no single phase units capable of providing enough heat, so they would have to upgrade their 3-phase supply. That just made the whole thing unviable, too expensive to go ahead. When we looked at the building, relatively simple calculations showed that improving a couple of the windows and some insulation on a part of the house that wasn't insulated makes it completely viable to do it on single phase, particularly with a ground source heat pump. And so this contractor really was losing out on the business, thinking, oh, we'll just put a big one in and hope they can afford it. But they lost the sale on that. So again, if we're going to help the sector move forward, highlighting things like energy efficiency, those sort of opportunities, and the whole system design, not oversizing, absolutely critical. So what we've been proposing is a course for system designers, really targeting groups like building services engineers, energy consultants on buildings. We want them to really understand, reiterate what should be straightforward, but just the emphasis on heat loss calculations, how they should do that. And as I mentioned, encouraging them to consider improvements that they could make, not just specify the heat pump, but look at improving the windows, improving the insulation, installing other systems like mechanical ventilation with heat recovery that can work well with the heat pump, but reduce the overall carbon footprint. Then we're quite keen to highlight the range of heat pump options that are there. So we've done some work looking at mine water as a source of heat pump, lukewarm water, which can really boost the COP of the heat pumps. We've had some funny reactions when we've looked at open source, open loop, river water or spring-fed heat pump systems. And they would have been very appropriate for those sites, but the contractors were very cautious of them going forward. Then we want the course to look at the wider system design, whether that's optimizing the hydraulic design of the ground array, looking at smart control, integration with other technologies, managing systems like Legionella from storing water at the lower temperatures delivered by the heat pump, and then looking at heat distribution options. So as some of those examples, helping the guys on the course to really correctly size the heat pump, absolutely critical. And we're developing tools that we hope will help them specify the correct size of the heat pump, but will highlight opportunities for energy efficiency. So it's not simply plugging numbers in and getting an answer out. It will encourage them to explore opportunities to reduce the energy consumption of the heat pump. Also looking at highlighting both the peak demand, the size, the rating of the heat pump, but to properly size the ground array, understand the annual energy demand. We got some properties that we looked at which were largely used for hot water in the summer, needed a relatively small heat pump, but quite a draw through the summer months for water heating. Other sites, like the building here, which was supposedly initially was going to be topped up with a gas boiler, but would have meant the heat pump was running at a much higher duty, the initial heat pump. So the ground array would be a relatively large demand compared to the rating of the heat pump. We will cover the fundamentals of heat pump, really to emphasize to the students on the course the benefits of any work they can do to improve the supply temperature or reduce the distribution temperature, so really maximize the COP. And then reiterate to them the range of heat source options, closed loop, open loop, wine water, through to seawater examples, other projects like that. Open up the broad range there. So we're doing work on boreholes and developing tools to help the specification of the boreholes, evaluating opportunities for fewer, deeper boreholes versus larger numbers of shallower ones. So what geological aspects need to be considered there. And then choosing different options for shallow slinkies or straight pipes going through, or integrating with the construction energy piles and systems like that. In another area that we've seen some poor demonstrations of is the hydraulic design, correctly sizing the pipework to the ground array, which can lead to poor conductivity with the ground or oversized pumps circulation going around. And we've seen some examples where the COP of the heat pump has really been compromised by over-specifying the pump for the ground array side. As I mentioned, keen to highlight opportunities for water source heat pumps and open loop systems, and to understand things like the environmental impact. So if you are taking water out of a river, potentially dropping the water temperature, we've actually had examples where that's been viewed as a benefit to the local environment, but it needs to be understood and the impact assessed going forward. Then if we are keen to include air source, because there are times when that's appropriate, but we've seen examples again where things like noise from the external fans has not been considered. We're relatively close to the sea. We've seen projects where there's been real corrosion issues, salty air coming through the fans and really causing poor corrosion there. And helping the students on the course properly understand the seasonal efficiency from things like an air source heat pump. Then we will cover the wider system design, clarifying that if you've got lower water temperature, you might need a slightly larger hot water cylinder, and how issues like Legionella would be managed in a typical system. Again, give the students tools to assess the advantage of different heat distribution systems. So how well would underfloor heating work compared to radiators or other systems, warm air blowers? And then we've had a number concerned about the integration of a heat pump with different heat systems, whether that's solar thermal, providing hot water in the summer, or a wood stove, log stove, and how that might integrate well with the heat pump system, and how that can be done safely without compromising the performance going forward. And then, yes, perhaps cost-wise, a gas boiler might be retained for peak heat demand, but what are the implications for the ground loop design, and also things like metering the heat going forward. Keen to cover both individual homes and then multiple properties, the implications of district heating and different opportunities there for distributed heat pump networks or for large centralized plants. And then interesting areas in smart control, looking at controlling the heat pumps to maximize the use of electricity at times where the price is low or the carbon intensity of the grid is low, and how that could work with other grid batteries and renewable energy systems on the building. And that's work that we're doing and demonstrating on a property on campus. So we're keen to work with existing frameworks like microgeneration certification scheme, but show how that can be applied to larger projects, and designing tools like the MCS tools, but ones that are more intuitive, not just provide the answer, but help people to understand the engineering behind them. We're still working to try and look at the course that we're developing will be accredited. So working with local heat pump associations to find a route to accreditation of our course. So we're keen in discussion, explore if you think this is relevant, if there are other areas that we should be including in the course, and other aspects which I look forward to discussing in the follow-up discussion. Thank you all.
Thank you very much, Richard, for your presentation. Now it will be in a second the turn for Julie. And just give me a minute. Okay. I'm sorry, I'm having some difficulties with my screen sharing. It should be fine now. Okay, now if you're ready, Julie, you can proceed with your presentation.
Okay, well, thank you. Hello, everybody. I hope you can hear me well. My name is Julie Beaufils, and I'm the General Secretary of Europon, which is the European Association of Electrical Contractors. My presentation is going to be a bit different because, well, first we will go a bit beyond heating and cooling as electrical contractors. And also I'm going to present a project which is EU-wide, but which is not a European funded project. Well, I'll come back to that. So I'm trying to change the page. Okay, so yeah, just very, very shortly, what are electrical contractors? Just like heating and cooling installers, we work a lot on buildings. We actually work very much hand in hand. So working on electrical systems, connecting devices together, more and more working on energy management, of course. So this goes from installation to operation and maintenance, as well as obviously planning, advice, and working on circularity. This sector represents 1.8 million professionals across Europe, 300,000 companies, mostly SMEs. And even though building is our main focus, whether it's housing or commercial industry buildings, we also work on infrastructures and increasingly on e-mobility. So a very shared concern among electrical contractors associations in Europe is the issue of skills from two perspectives. The first one is that we have a huge lack of skilled workers, while job opportunities are tremendous and are, we think, going to grow with the recovery, with lots of initiatives at the EU or national level regarding, climate neutrality by 2050, switching an energy transition, and so on. So we need lots of workers, but we also need to work on the skill sets of the workers, because everything is changing very fast. And so that's from this observation that we launched last year, actually almost exactly a year ago, the Skills for Climate campaign. So it's really mostly so far a communication campaign, but to really raise awareness at the level of policymakers on the need to address the lack of skilled workers and climate-related skills across Europe, and also to really start to, raise awareness on the job opportunities and attract new workers into the field. So in May this year, we relaunched this campaign, which was quite successful last year with lots of great contacts taken at the EU level. But we relaunched it in May because we wanted to put the skills agenda really high on the EU focus before the Commission released its recovery strategy. And so we developed this idea of a virtuous circle by investing in skills and climate-related skills. We want to really materialize the energy transition that everybody talks about, but which will need workers to really take off. And this will boost growth in the economic sector of clean energy, of digitalization as well. And finally, we will, create more jobs and achieve climate neutrality. So for this campaign, we got the support of many European associations, including EHPA, by the way. And yes, we really tried to show the great diversity of jobs because, for example, in the electrical contractors, everybody has usually this idea of, the electrician working with cables, but there's really more to it, and it's changing very fast if we have the right amount of workers and the right skills to switch it on. So there are diverse obstacles which challenge the rapid improvement of climate-related skills for electrical contractors across Europe. I think it's important to start there. So, well, first, challenging the phrase across Europe. One difficulty is that skills is not an EU competence, so it's very difficult to work on it at the EU level. There are isolated projects. You've mentioned great projects before in this webinar, but the issue of harmonization is very complex, can meet lots of refusal or barriers because curricula and competencies are very different from one country to the next. For example, in the electrical contracting sector, there's a huge culture of apprenticeship. Apprenticeship is really one of the foundations of the careers, but apprenticeships vary a lot in terms of duration, in terms of the split between theoretical and practical learning from one country to the next. So it's very difficult to work from a European perspective. Also, electrical contractors are part of a branch which faces specific obstacles for upskilling or reskilling. So the first aspect, which is very true in the construction sector as a whole, to be honest, but it's not necessarily the case for other sectors which are working on skills. One big issue is that in our sector, most companies are small or medium enterprises, and they can actually be very small companies. You have lots of single entrepreneurs working in the electricity sector. So this means that they actually, even before talking about human resources or financial resources to upskill, they actually have a lack of time to do the research, go in a training center, upskill. That's the first issue, because it's a very scattered profession. Then another issue is the poor image of vocational education in most European countries. It's difficult to attract enough new workers. We are very happy to see that the figures are rising in most countries, every year, but it's very slow, and there's still this reluctance of going into technical education when you could get to academia. There's really a different perception, and it often comes from society as a whole. It often comes from parents, from teachers. So that's something which is very difficult to change. And finally, really more on upskilling, the profession is aging. So, well, it's easy for me to say as a young woman, but it's true that we often acknowledge in the profession that aging professionals are less prone to change, upskill. There are some barriers to work on digitalization, for example. And so this is really a strong pattern in the electrical trade. As for rapid improvement, another challenge that we face is that technologies are very fastly evolving. And so this challenges curriculums, because the moment you've implemented a new curriculum, technologies are changing again. There are new technologies that could be integrated together in the built environment. So there's a lot of hands-on, on the ground training to do. But it's a very challenging situation. And finally, when working with climate-related skills, this leads more and more electrical contractors to have this advising role for consumers, to tell them about those new technologies that clients don't know themselves. That's also a way to show clients how to connect, integrate different devices in the house or in the building. For example, as mentioned before, connecting solar panels with storage and heat pumps in the same building. But to be able to do this advising, to let clients know about also public support for this kind of retrofitting, there's a need for soft skills as well. So it's not just about the techniques, it's also about knowing how to advise, how to communicate, how to incentivize clients to go for the energy transition. So I've been talking a lot about obstacles, and the conclusion here could be, so we should do nothing. Well, of course, no, I wouldn't be here in that case to talk with you. And so there are lots of areas, but lots of areas for improvement at the European level. The first thing that we try to do at Europe On is to learn from other national good examples, work on best practices, because there's nothing better than an initiative which is really on the ground and which is demonstrating its worth to inspire other initiatives. So, for example, on upskilling, we've seen a massive rise in e-learning since lockdown. Lots of trade associations have been working on this a lot, because electrical contractors have not always been allowed or didn't always have the opportunity to work during lockdown periods. And this is coming back now. So this is still of relevance to be able to adapt and, well, try to turn this situation into an advantage, at least from a skilling perspective. We are also working in different countries on new apprenticeships, which are more focused on system integration, energy management, and we're trying to create this forum between associations so that more can take the example of new programs and try to implement it their way in their country. Because yes, one thing that I didn't mention is that about apprenticeships from one country to the next, trade associations are more or less involved. For example, in a country such as Germany, it's really the trade associations which has the leadership on proposing a new program and working, of course, in consultation with schools and Ministry of Labour and Education. But in other countries such as France, it's really more coming from the public sphere and then being implemented in schools in consultation with trade associations. So again, it's really shifting from one country to the next. We are also interested in pilot programs in some countries where trade associations and schools are trying to reskill workers from sectors which have been very harshly hit by the corona crisis, so that they can be reskilled in sectors such as installation. But to improve skills at the European level, a precondition for us remains to improve the attractiveness of the sector for young applicants. And this is why when we relaunched our Skills for Climate campaign in May, we were very happy to receive a positive feedback from the European Commission. We started discussing with them on a regular basis. And so we are working with them on the so-called Pact for Skills, which will be launched by Commissioners Schmidt and Breton on the 10th of November during the Vocational Education Week of the EU. So we are still working on this process of dialogue and trying to, concretely find solutions here and there, more than EU-wide, this is true, to improve the skills agenda. One last topic that I wanted to mention very briefly, because I see that time is running out, is that we are also now shifting our perspective on our reflection, on skills, to try to find new business opportunities which are rising or which are completely new since the COVID crisis. And this will also impact the way we work on skills and which skills we need to improve in the coming months and years. And that's all for me. So, well, thank you for the occasion to speak with you, to listen to the other speakers, and happy to start the Q&A session.
Thank you very much, Julie, for your presentation. Now, don't mute yourself, since I think it's a good moment for starting with you. In your last sentence for your slide, you were mentioning that you must convince different professionals of the new business opportunities in climate-related services. So what new business opportunities do you see after COVID, and how does it affect the skills?
Oh, okay. Thank you. Yes, so at the level of Europon, we are currently working on a new study, which is quite business orientated, because we want to bounce back in this crisis, which is lasting. And I think that the recent lockdown announcements in several EU countries are confirming this. So we are trying to reflect on how we could find new business opportunities, either in those lockdown or almost lockdown situations, or after the end of this period, which will be very difficult for all economic sectors. And thinking about that, well, we've been, of course, paying a really big attention to the recovery programs, which are being announced both at the European and the national level. We see that there is a lot of room for the so-called green and digital transition, which means that we really need to focus the skills development programs on energy transition, on digitalization. Lots of people, most of European people, okay, maybe not most, but lots of European workers are currently working from home. So this calls for more connectivity, for example. So this is a business opportunity for electrical contractors to improve fiber optic, to improve connectivity in houses, in buildings as a whole. So that's something that we should work on from a skills perspective. That's one example. Another example here is contactless technologies. We need to work on installing, operating and maintaining contactless technologies in all buildings which receive public. So that's the kind of things that we are thinking about. Yeah, indoor life quality. Well, there's obviously room for to progress on this, because people are spending way more time at home. Home is the new workplace for many of them. So there's definitely an impact for ventilation, heating systems, but also for smart devices, and for yes, connectivity again. So that's the kind of topics that we are addressing at the moment. from the skills perspective and the recovery.
Okay, thank you very much for your answer. We have received a question by Amar Capinale. I hope I'm pronouncing the name right, for Serena, which says, what is the percentage of reduction in carbon and cost in residential pilot projects?
Yes, thank you. So as I said, now we in our 4 residential demo sites, in the 3 residential demo sites, the technologies have been installed, and now we are in the monitoring phase. So we are actually monitoring the performances of the technologies involved, and we are also monitoring this data. So as of today, I cannot tell you precisely which are the data of reduction, because this phase is still ongoing. In January, so let's say in 2 months from now, 3 months, we will publish this data. So I invite Amar and all the other people interested to keep an eye on the Heal4Cool website, and in there we will have a full report with precise data.
Okay, thank you very much for your answer. We have a question also for Johann. It mentions you spoke about the CEN-CE training and the certification scheme, but has it already started? And then if it has started, how we can get all the information? Can it be done online?
Okay, thank you, Irene. Yes, it has already been started, but so you can register to some of the training modules already on the CEN-CE learning management system, and all the information how to do it and the links you will find on the CEN-CE website, which is also mentioned in the presentation. The link is in the presentation. But it is still, we are still in the pilot phase. So let's say that really the real training or the rollout of the whole training all over Europe and even more than Europe, because I saw that there are some questions from India, and this can also be done online. This will start probably next year when we had more contacts with national associations.
Okay, thank you very much. Then regarding the, how do you think this CEN-CE EU-wide training and certification can be implemented EU-wide?
Yes, okay. Yes, this is a very important point. And it has been also mentioned by Julie, and she mentioned that it was skills is not an European competence, so it's a real problem because people cannot work on the other side of the border very often. So it will go through mutual recognition, and with those we have to start the discussions with national professional associations, and then they will recognize the CEN-CE training scheme to be compliant with national scheme. So this is the way how it will goes, because sometimes, very often, there are some, how to say, some benefits or some accreditations or some other requirements related to this national skills, and this is why it can go only at this point through national professional associations. And then we will also contract with national training and scheme providers. But if you do not need an accreditation or something like this, if you are only interested in between brackets, how to make on the system approach, and it has been also mentioned already several times, how to integrate a heat pump, a PV, thermal solar, or things like this, how to size the storage and things like this. If you're interested in the background and the technical information, but you do not need a national accreditation, then of course but it's you go to the CEN-CE training online learning platform, and you can also have trainings there.
Okay, thank you very much, Johann. Then we also have a question for Richard. Richard, you were talking about the case in which you were working in, and like the heat pump not being efficient and not working fine. But what is the worst example of poor design of a heat pump system that you have ever seen?
I suppose some of this poor design has then meant that the systems didn't go ahead at all. So it was too expensive. We were lucky in this one that we could catch that and then redesign and respecify the system. There are other examples, one where the energy used to run the pump for the ground loop circulation system was so poorly sized that it meant the heat pump had a COP of almost 1 because of the energy used to run the pump. So it really defeated the benefit of using a heat pump system on that site.
Okay, then there's another question for you, Richard, actually. You were asked how, well, since you're also like doing this training that people can join, how would you encourage potential system specifiers to sign up for training, for instance, since we are here discussing this theme today?
Yeah, no, you're quite right. That's a very relevant point, because some of these engineers think they've been sizing gas boilers or other systems for years, perhaps, and think they know this. And there are subtle differences that we need to communicate to them to encourage them to engage with the heat pumps. It's where possibly things like accreditation or certification might be needed, that in order to specify a heat pump, you have to show that you've done the course. Encourage them to sign up to do our course, but to design a better system in the first place. But that is a challenge. How would we convince? And I suppose it is perhaps citing some of these case studies, what can go wrong, that might encourage them to sign up and learn a bit more about how to do it properly. The other way we're hoping is that actually just the tools will, developing and teaching people how to use some very intuitive, user-friendly tools will help with that as well. So they'll get access to tools which will give them more insight into the physics behind the systems. So for the hydraulic design, the Reynolds number in the pipe flow, not just tell them, right, put in a 50 mil pipe, but try and explain why that works. So give them insight there. Similarly for the heat loss, it's really easy then with the tool to look at energy efficiency options and see what the benefit in terms of the size of the heat pump and the energy consumption would be from making those changes.
Okay, thank you very much. Now we just received a really short question also for you. Since you're since the COVID-19 has changed the paradigm in which we are living in, and now we're heading to online training, is there any portal right now in the works, or at least courses, type of portal like in the works for you, like for taking, like for carrying out the training, or how is that situation going?
Yeah, so yes, we are in changing situations. When we started looking at this, we were, before COVID, we're very much thinking about doing a large proportion of the course online, in person, so we could actually show them an installation, go and see a borehole being drilled, and perhaps also have some practical element where, although the course is focused on design, it's useful to understand some of the installation principles so that they would get their hands on a heat pump and see the installation work. But increasingly, looking at online platforms that will we hope then access a wider audience so we can reach out to more people. And instead of going to see a borehole, we'll do a video tour of the borehole installation. And so we can still cover that material in an online platform. We are looking, there are a wealth of different portals and different opportunities there that we could use. And we haven't finalized which one we're going to use yet, I'm afraid.
Okay, thank you very much. Building up on this theme of online training, Serena, you mentioned about the different trainings that had to be taking place online, but which are the next trainings you're planning for Heat for Cool?
Yes, thank you, Irene. What we aim at the moment is, so the best option would be to be able to do physical training, because as I said, maybe when you have to interface with installers and to showcase the technology and how to install it, how to do the works is easier when you can do physical training. For the time being, since we consider the current health situation, we are only planning online trainings. So next training will be maybe dedicated to installers specifically, and will be published on the Heat for Cool website.
Okay, thank you very much. Then we have another question for Julie. As I think I mentioned in the beginning of this online seminar, now the European Commission plans some measures in order to trigger the renovation wave. Then I would like to ask you how happy you are with their take on skills.
So the renovation wave is a strategy that was presented by the Commission on the 14th of October. And the main ambition for it, well, at least the selling point that they advertise, is that they want to double energy renovation rates across Europe in the next 10 years. So it's very ambitious. Lots of people will say that it's not ambitious enough, but doubling is very ambitious in terms of activity. And we talk about energy renovation, so quite rather ambitious retrofitting or renovation. So this is a great objective. And this, if it's applied, this would lead to a lot of job creation and a need for better skilled workers with a way more varied skill sets, because then you can offer lots of services and integrate lots of technologies which are still not very present in the built environment. So this is a really thrilling opportunity, and I was also very happy to see that the skills themselves have their own chapter or session, I don't know, portion in the renovation wave strategy. So it's definitely one of the angles which has been really important for the Commission when they drafted this renovation wave. Then what are they going to do with it concretely? This is a real question for us, because so far, even though the ambition for renovation rates across Europe is very ambitious, the ambition is very ambitious, is not the best phrasing, but even though they have a high level of ambition for renovation, they don't really say how to work on it. They really leave it a lot on member states, but we were hoping for more clear guidelines, and especially we were hoping for budgets which would be really earmarked for renovation, and this is not the case. So that's something that worries us, because to put it simply, you need to show the money to be sure that there will be incentives and that there will be a real implementation after. So this is something that's worrying us a bit, and that's something that we will be addressing. I'm taking this occasion to make just a little bit of promotion, but that's a question that we will be asking to the Commission in our own annual conference in a few weeks on the 18th of November, to know if, to what extent skills are a pillar of the renovation wave.
Okay, thank you very much. Unfortunately, time is running out, so this is the end of the Q&A session. I want to thank all the speakers for their really interesting presentations and all the attendees for being here and for being participative in the Q&A. Tomorrow you will receive the video of the session as well as the presentations. If you have any more questions, don't worry. I really encourage you to write directly to the speakers, as I'm sure they will be glad to privately engage with you. Thanks again to everyone, and I wish you a very nice day, and I hope to see you in other online events soon. Thank you very much, and bye-bye.
Thank you. Bye.